pointer to function. So I would like to discuss two small topics, pointer to function and pointer to structure. Okay. So before going in detail, I want to say one thing. So we already studied while executing a program, the program will be in main memory. So here in this example, I have a function. So this program must be loaded to main memory by some software called loader. So this function must be bring to this memory. I have another function, main. For execution, this also has to be come to memory. And here I have some variables. S, A, B. Everything must be in memory. For execution, everything must be in memory. Okay, that we all know. For execution of a program, the program must be loaded to memory. So our point of discussion is this function also will be in memory. So it will be stored in some bytes, some memory location. So since it is in memory, it will have some address. So what will be pointer to function? If we store that address of a function in some variable, we can call that variable as a pointer to function. I already told you everything will be in memory during execution. Everything in memory during execution means anything in memory will have some address. So if the address of that function part will be stored in a variable, we can call that variable as a array of point. We can call that pointer as a pointer to function. Give me 1 minute. Okay. So next we will go through each and every point. In C, like normal data pointers, int star, char star. Int star means it will point to an integer data type. Char star means it will point to an integer data, etc. We have pointer to function. Unlike normal pointers, as a function pointer points to code, not data. Earlier we have studied it is pointer to an array. Array contains some data. Pointer to a variable. Variable contains some data. Here there is actually no data. That here instead of data we have code. That means program. This function is called a code. Instead of data we have code. So since that code is in memory, it also has some address, and if I store that address in some variable, we can call it as a pointer. Typically, function pointer stores the start of the executable code. So here I have a function. So here this will be the starting point. In some memory location, this will be stored. This float add, float a comma, float b. It is not stored as it is. It will be converted to its equivalent binary, and it will be stored. So that address location will be the actual function pointer. Typically, function pointer stores the start of the executable code. So next is the syntax. Return type. Return type means return type of the function. Then within bracket star function pointer. This is actually a identifier. Similar to star p, star ptr, we have a function underscore pointer. Then I have to put a bracket. Within that we have to write type 1, type 2. Type 1, type 2, etc. are the type of the arguments in the same order. If it is float, if the first argument is float, here also it will be float. If the second argument is float, here also it will be float. So this is the syntax. So example, here in this line I have an example. I am writing function pointer variable for this function. For this function, I am writing a function pointer variable. The return type of this function is float, so that is return. Then I put a bracket. Then I write star fptr. It is an identifier, that means function pointer. It have two arguments, both are float. So within bracket I wrote float comma float, float comma float. Then I have fptr equal to add. What is add? Add means function name. Function name. So that function name actually refers to the starting address of the code. Starting address of the function. This one. Typically function pointer stores the start of the executable code. Add also contains this address of, add is the function name. Similar to array name, function name also contains some address value. I already told you array name is a pointer. Similarly function name is also a pointer to the code. So that is stored in fptr. So actually fptr can hold the some address value of a function. So this is how address is assigned. Then how to call the function using function pointer. We all know how to call the function with the help of function name. We just call add 5, 6. Here what is happening, we have a function pointer fptr that I have to return within a bracket along with a star. So star fptr, again put a bracket, then 5, 0, 6, 0. This is the way to call a function using function pointer. Call the function using a function pointer. So the result is printed. This one is the another method. This is similar to the function call using function name. Function call is function call using function name. This is same fptr 5, 0, 6, 0. It is same as add 5, 0, 6, 0. So what you understood? Add and fptr are name given to same function. Are name given to same function. Both refers same function. From this it is clear. So most of us have two names, our normal name and a nickname. Similarly here I am assigning one more name to the function add, that is fptr. So to add that one, you have to write these two statements. First you have to declare fptr as a function pointer, then you have to assign address of that function to function pointer. For that I used this line. Is it clear? Is it clear? If it is clear, please respond with a clear message. So already done that program. I will execute it. ptr. Okay. Function pointer. Here I will give one more statement. Instead of fptr I am giving add. Everything will give the same result. This is pointer declaration. This is address assignment. This is our actual function. All outputs are same. 11.000, 11.000, 11.000. Okay. Next is array of function pointer. Array of function pointer. So array of function pointer means it is an array of pointer. It is an array of pointer. Array of pointer means that array will contain some address values. That array will contain some address value. Here also I have an array. That array will contain addresses of some functions. Addresses of some functions. So it will be clear when we do the example. But the one point you have to taken care of it is, if you are declaring some array of functions, the return type of all the functions must be same. The return type of all the functions must be same. And also the number of arguments also must be same. And also type of arguments must be same. Type of arguments also must be same, because while declaring the function pointer, because while declaring the function pointer, we have to specify those things. If one function's return type is int and some other thing is float, there will be an ambiguity, there will be a confusion. So to avoid that, you have to follow the same pattern. Same pattern means every function will have the same return type. That return type has to be written here. Then star fptr, that is an identifier. Since it is an array, we have given a box bracket. Then we have to pass the arguments. That means this add, sub, mul, div, everything will have two arguments and of type integer. So for illustrating, I am going to implement a program to execute arithmetic operation. I am going to write a menu driven program. If you remember, you just recollect what is a menu driven program. I am going to write a menu driven program with the help of pointer to functions. Pointer to functions. So function pointer, menu calculator, menu calc dot c, save. Okay. So I am modifying this program. So here I have four functions. First one is add, second one is sub. There I will write return a minus b. Next one will be mul, that is returning a star b. Then I have div for division. There I have a by b. Okay. This is a function pointer. Already in the previous example we have written this as a function pointer. So now I need a function pointer array. So I need a pointer array. So just give a box bracket. That's only a difference. And I have to initialize equal to add. That means fptr of, so here I have, okay, just listen. I have an array called fptr 0, 1, 2 and 4. 0, 1, 2 and 4. So the size is not defined anywhere. So it will be clear when I write the remaining part, sub mul div. So the array contains 4 elements. So fptr of 0 refers add. fptr of 1 refers sub. fptr of 2 refers mul. 4 refers division. Okay. Any doubt in this statement? If anybody have any doubt, please ask. Okay. Writing the remaining part. So I am going to write a menu driven program. So there will be a do while. First I will print the menu, printf /n one for add, 2 for sub, 3 for multiplication, 4 for division, 5 for exit. So user will enter a menu. So scanf, will enter a choice, scanf %d, C. Int C. because C is an integer. So user read a choice. If the choice is 5, no need to read the two values. Anyway, here we are going to add two numbers, subtract two numbers, multiply two numbers, divide two numbers. So if the option is 5, there is no need to read two numbers. We have to read two values only when the option is 1, 2, 3 or 4. That means when the value of C is less than 5, we have to read that choice. So if C less than 5, I have to do something. Printf. Enter two numbers. Scanf. So here all functions, the parameters are float. So I am declaring it as float. Percentage %f, percentage %f, percentage %f, comma, ampersand a, comma, ampersand b. I am declaring two floating point variables also, a, comma, b. So if the choice is less than 5, I have read two values. If the choice is 1, which one I have to call? If the choice is 1, I have to call add. If the choice is 1, I have to call add. If the choice is 2, I have to call sub. So this add, sub, mul, div, everything is in array now. So the zeroth position refers to addition. So I'm making a call like this. S equal to, this is to store the result, fptr of, actually the choice is 1, array it is in 0. If the choice is 2, it is sub, that is in 1. In array it is at 1. When the choice is 3, it is multiplication. In the array it is in 2. So I am making C minus 1. So if the choice is, I press this 1, S equal to fptr of 1. Sorry, fptr of 1 minus 1, that is 0. So it refers add. If the choice is 2, the value of C is 2. What is 2 minus 1? That is C minus 1. C minus 1 means 2 minus 1, that is 1. What is fptr of 1? Sub. That's why here I subtracted 1 from C. And have to pass two parameters also, a, comma, b. Here it is not percentage, here it is ampersand, a, comma, b. Then I am printing the result, printf /n, result equal to percentage %f, comma, s. So then here I have a do, so I have to write a while condition, while. So same condition what we have written in the earlier program. This menu has to be printed only when the ended option is 1, 2, 3 or 4. If it is 5, no need to repeat. So I am writing while C less than 5, and you have to put a semicolon. So I am executing the program. Here I have some error. Array size missing in fptr. I think I made some mistake. One minute. Actually, I think this is here, I think. Okay, give me 1 minute. Okay, sorry. Here I have given a semicolon. That may be the problem. Okay. Now entering option 1. Okay, here I missed the ampersand symbol. 1. Add two numbers. I am entering 5 and 6. So I got result as 11. Again the menu is printed. Now I am typing 2. Option is 2. I am giving 9 and 6. Result will be 3. Now I am giving option 3. 5 and 6. Result will be 30. Now I am giving option 5. Sorry, 5 means exit. So I have exited from the program. Similarly, it will work for division also. So here I am giving 4. 4 and 2. The result will be 2. Anyway, this part you are clear because we already studied in menu driven program. The only thing you have to understand here is this one. How to create a function array, function pointer array, and how to call that function. These two are the only new things. Actually, it is a modification of the earlier program. Any doubt? Please ask. So for the past few sessions, no one is asking any doubt. So is it clear for everything, or you didn't understand anything? Okay.
Sir,
Okay. Doubt.
sir,
Ask. Tell. Shashikant.
what I said, it will be zero, sir.
So it is not clear. Which line number?
Then
Can you type it in the chat
the
box?
line,
Please type it in the chat box. Shashikant.
hello.
Tell Shashikant.
Telling that uh, what I said, it will be zero, sir. It will the value of add of any number.
So actually your doubt, I am not getting you. If somebody understood what he asked, please tell me. Shashikant, your voice is breaking. So can you please type it in the chat box? You can type it in the chat box. Nuja MB. Nuja MB.
Yes, sir.
So in line number 30, why I wrote C minus 1?
അത്
പറഞ്ഞോ.
FPTR 0 അല്ലേ തുടങ്ങണേ അപ്പോൾ
Okay, FPTR is starting from 0, but our menu is starting from 1. Okay. Mary Elena,
Yes, sir.
any doubt in this program?
ഇല്ല
എല്ലാം മനസ്സിലായോ? Okay.
മനസ്സിലായി.
Okay. Okay, Shashikant has, for add you have taken FPTR 0. But in the program you have written 1 for add. Okay, very good doubt. So here I have written 1 for add. So definitely user Shashikant. So I have in the menu I have written 1. So definitely user will enter 1. User must enter 1. So C will get the value 1. So while calling, I have called by C minus 1. So if it is 1, here C minus 1 will produce the value 0. That refers to FPTR of 0. Is it clear, Shashikant? Here I am subtracting 1. So suppose I am taking 4. Sorry. It is actually 3 here. Okay. Suppose I am giving value 4. 4 means division. So there is no such cell with index value 4. There is no such cell with index value 4. So C is less than 5 because it is 4. So two numbers are stored in A and B. Then I am using FPTR C minus 1. C minus 1 means 4 minus 1. 4 minus 1 means this 3. FPTR of 3. Shashikant, is it clear?
Yes, sir, clear.
Okay. So that's why I told you. If you understand line number 30 and line number 21, you can understand everything. Okay. Sometime you may ask to write some function with the help of function pointer. Okay.